When two or more transformations are combined to form a new transformation, the result is called a composition of transformations. In a composition, the first transformation produces an image upon which the second transformation is then performed. So in this podcast, we're going to be learning how to perform composition of transformations, more than one transformation. So here we have an example that is already done for us. So here we have our original is right here in blue, and this is in your notes. And there we go. So I'm going to darken it so you know which one I'm talking about. All right, so this is our pre-image, so you can label that in your notes. All right, so the pre-image is RS, and R is at 1, -3, and S is at 2, -6. And we want to graph the image of RS after the composition. So the first part of our composition is a reflection in the y-axis. So I'm going to write that over here. So reflect in the y-axis and over the y-axis are the same thing. I'll just put reflect in y-axis because it takes me less letters to write in than it does over. All right, so remember when we reflect over the y-axis, our x becomes the opposite and our y stays the same. So xy becomes -xy. And that doesn't fit very well there, so I'm going to just move that down over here. Maybe I'll move this up. All right, so if you notice, we were at 1, -3, and 2, -6. All right, and after the reflection, it's now -1, -3, -2, -6. And then we have a rotation 90 degrees about the origin. And actually, they're forgetting to tell you something, because that's actually not enough information to actually perform the transformation there, because they forgot to tell you which direction. So you can see from the diagram which way they meant to tell you, and that is counterclockwise. So 90 degrees counterclockwise about the origin. All right, so remember on a 90-degree rotation counterclockwise, xy becomes, so x and y are going to switch. The first one, so right now they're both negative, right? So when they switch, the first one's going to change signs again, so it's going to be -yx. Right? In this case, they're both negative. If they'd both been positive, right, they still would switch, and the first one's going to change to the opposite sign. Right? So we have -1, -3. I'm actually going to write that over here, and I'll put it over here. So for that 90-degree, and actually I'm going to write this in green just so it matches the words when you're looking at this, so you'll know which ones we're talking about. So xy on that 90-degree switched and became -yx. Right? So the points that we have were, and it's always good to use a matrix to organize your points, especially on multiple transformations. I'm going to show you how to do that in the next few examples. So we had -1, -3, and 2, -6, -2, -6. All right, so then we're going to have, for our matrix here, -yx. So we're going to apply -yx, which means we're going to switch and change the sign of the first one. All right, so when we switch, right, so this was R and this was S. Right, so instead of having -1, 3, we're going to have 3, -1, because the first one's also going to change signs. Instead of -2, 6, we're going to have 6, -2. And that's what we have in that last example there, 3, -1, and 6, -2. Right, and so right here is that 90-degree transformation, 90-degree rotation. And here's our point of rotation. Right? And then remember, we learned this was the angle of rotation right there. Okay? So these are all little individually they're a review, but together it's our last concept for transformations, and that is composite transformations. Right? So when we do composite transformations, you're not going to go back to the pre-image. Right? You're going to transform the image. Oops, there goes my pen. So this is the first image. I'll have to go retrieve my pen because I'd like to write in green now. And then this is the second image. So let's look at the next example, which is not in your notes. Actually, this one is in your notes. It's the one after that's not in your notes. So glide reflection. It's just a way of describing a transformation where we have, it's a composition of transformations in which we have a translation and a reflection. So with a glide reflection, it's an example of a composition of transformations in which every point P is mapped to point P prime prime. Right? So it's prime prime because we're doing two transformations by the following steps. A translation maps P to P prime. A reflection in line K parallel to the direction of the translation maps P prime to P prime prime. Right? So let's take a look over here. So this one is the original, the pre-image. So in your notes, you can mark this one here as pre-image. This right here, where we have these arrows, these our lines here with those parallel markings on it, that's the vector. Right? So this is our translation vector. So every point is going to move in that direction. Okay? And that's what this little arrow here is showing you. See, watch it moving. Whee, it's moving. Right? Once we've moved according to the vector, we're going to reflect over a line. That line is always going to be parallel. See, so notice this one here is also parallel to the vector. Right? So our line of reflection, and I'm going to write in line of reflection, that's always going to be parallel to the vector. Right? So let's actually put all this in your notes, and let's also add line of reflection is parallel to the vector, that translation vector. And this is true when we have a glide reflection. Not every time we'll be doing a glide reflection, only sometimes. Right? But that is a type of composition of transformations. And then so right here, P prime, Q prime, that's our first image. And then once we reflect over the line of reflection, which is that right there, right, we get our second image over here. Right, so that's the second image. So we'll always have a first image and a second image because we're always going to graph both. Sometimes if you're asked to figure out the composition of transformations, sometimes they'll give you both the first and second, and sometimes they won't. So if they don't give you the first and second images, then there may be more than one way to get to that same point, and that's okay. But it is easier when we have both, and we'll always graph both. All right, so this is the one that's not in your notes. We have the this is showing a glide reflection. So the vertices of triangle ABC are A 3 2, B 6 3, and C 7 1. We want to find the image of triangle ABC after the glide reflection. And so notice I have matrices, and those matrices are really going to help you keep organized, especially when you have more than one transformation. It is real easy to make an error and transform the wrong image or the wrong figure, right? So if you don't have it all neatly laid out, instead of transforming the first image, you might go back and transform the pre-image, right? Or you may transform some points and not all points. So for the composition, I do want you to have a matrix, and that keeps everything nice and neat. It's just so much easier. You're not going to be struggling because these all follow rules. All right, so let's look at the first one. Our first is a translation, and our translation is x minus 12y. So that means we're moving 12 to the left. Or we're going to subtract 12 from each of the from each of the x coordinates, but the y isn't changing at all. Right? And so this is our translation. Xy goes to, I'm not going to fit that in there, x minus 12y. Well, I don't think I can fit that in there. So I'm not going to try to put it in coordinate notation. Instead, let's just use a handy-dandy vector. Right? So here, and I'm going to write it like that. I'll just write the other way. It looks a little neater. Negative 12, 0. But we know the first is always the horizontal and the second is always the vertical. So there we go. All right, so now to get our first image, all we have to do is translate according to that rule. So we're going to subtract 12 from all of our x coordinates and not do anything to our y coordinates. So the y coordinates, I must just write them in because they're not going to change. All right, so 3 minus 12 is negative 9, 6 minus 12 is negative 6, and 7 minus 12 is negative 5. All right, and if we look, that's the correct points for our image, right? So this is the first image right here, and notice all of those points match. Now when I have it written like this, right, I'm not going to get confused over what to do next. I actually always set up all my matrices first, and I just leave it blank where I still have to get the points. So just like I had A prime, B prime, C prime, and A double prime, B double prime, C double prime are blank, that's just how I set it up. Right? I know what AB and ABC is because we're given that. We're given the translation vector. We're given it in coordinate notation, so I just write that next. And we know the rule for reflecting over the x-axis, so I can write that next. And then when I do that, I've got my second image. So remember, for a reflection over the x-axis, right? So horizontal line, x is not going to change, y becomes the opposite. So since x is not going to change, I can just write all my x coordinates down. See how easy this is? Negative 9, negative 6, and negative 5. And my y's just become the opposite. So now they're going to be negative. Negative 2, negative 3, negative 1. Right? So when you do it like this, you're going to be more organized. Right? You're going to know what rules you applied. And anybody else looking at your work will also know what rules you applied. Let's get rid of that. Right? And so then you can go back and look at your work and you'll know what you've done too, as opposed to, how did I get this? What's this mess? Right? So when you stay organized, right, your work actually becomes your justification. Right? So, and then this was the second image. Right, so we're going to use matrices for all of our composite transformations to keep track of everything, and I want you to do the same. Right? And so sometimes I'll write it like the first one, like the negative 12, 0, like that. Sometimes on the reflections and rotations, I just write it like this, and I don't actually put it in a matrix. But I'm still applying that same rule, even if I don't write it vertically. All right, let's go to the next one. This one's in your notes, right? So this one, we're not going to be using any matrices because we're not finding the points. We are identifying the sequence of transformations. Right? So how we got from 1 to 2 to 3. All right, so let's look over our choices. And actually, rather than figuring out which 1, 2, or 3 is A, and B and C and so forth, let's figure out which one, A, B, or C, is reflecting the line M and then translate parallel to line M. Right? So if we make some notes next to each of the pictures, it makes it a whole lot easier. So if we're looking at the first one, well, notice we're just moving triangle 1 over to where triangle 2 is located. What kind of transformation is that? Well, that's a translation. So if I just write down my transformations, then it's going to be a lot easier to match. Right? I'm going to know what I'm looking for rather than reading through all the words. Think first, then answer. All right, so now notice 2 here, it's flipped over that line M. So that must be a reflection. Let's do the same thing for the other ones. Let's write down the sequence of transformations, and then we can match it exactly. All right, so now let's look at 1 to 2 for B. All right, well, they're not facing the same way, so it can't be a translation. Those aren't mirror images either. So this must be a rotation. We must have turned it. But now if you look at 2 and 3, they are mirror images across line M there. So then this one, this is a reflection. And so now if we didn't have this multiple choice part here, and you just told me translation, reflection, that's not enough. Or rotation, reflection, you need to put in more information. So just so you don't get confused, let's actually put in that information and then we'll match it. All right, so now let's look at our last one here. So we're going from 1 to 2. Well, those are mirror images of one another. That's a reflection. Right? And then we just moved it. So that's a rotation. So just so you don't just give me the type of transformations, that you're more specific, let's fill in the rest of this. Right? So for the translation, notice that we're moving in the same direction as line M. So let's put translation in the same direction as line M. All right, and then how do we get from 2 to 3? When you have a reflection, you have to reflect over something. What line do we reflect over? It's a reflection over line M. Right, so let's go over number 2 there and do the same thing. When you rotate, you got to rotate around something. We can't figure out, might not be able to figure out how many degrees that is, right, unless we match the corresponding points and we figure out the angle of rotation there. But that one won't be important for this one since there's no other markings given. Let's just figure out what we're rotating around. So you got to at least tell me what point you're rotating around. Here, this is a rotation about, oops, I want a green, but rotation about P. All right, you got to rotate about a point. Right, and then we reflect over line M. And the last one, our first step was, I put rotation on the last thing. Well, I'm sure I said translation. I don't know why I put rotation. All right, so it's a good thing I went back to these. So we have a reflection over line M. Oops, not line M. Line M. And then we translate. My cord doesn't want to stretch anymore. We have a translation. And notice we're going in the same direction as M again. All right, so now we've written it all in, and that's always a good way to do that. Write in your own words what's happening, and then look at the descriptions. So reflection in line M, then translate parallel to line M. What's that describing? Which one did the reflection first over M and then moved in the same direction? Right? Well, that was C. All right, so next to 1, we should write in C. Translate parallel to line M, then reflect in line M. Right, so notice A there, we translate in the same direction. That means the same as parallel. And then we reflect over line M. So this one was A. And then the last one, rotation about point P. And then we reflect over line M. Why, that's this one here, B. Right, so it's a good idea. Put in your own words, right? Really think it through, and then match. You'll have a similar problem in your homework. Let's continue on. Right, so this one is not in your notes. We have triangle JKL has vertices 6, -1. So 1, 2, 3, 4, 5, 6, -1. There's A. 10, -2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it goes right to the end. 10, -2. That's B. Or J and K. I guess I really wanted it to be A and C. J and K. So it went back to purple. I don't have I'm blue. I don't have a purple marker. I have to change the color. And then L is 5, -3. 1, 2, 3, 4, 5. 1, 2, 3. Right? And so that is L. All right, so here's our triangle, JKLM. There you go. But we're gonna find our points and then we're gonna graph. Always find your points first. All right, and when we're always going to use a matrix. All right, so JKL, just record your points. So that was 6, -1, 10, -2, 5, -3. All right, and then we have a translation along the vector 0, 4. Right, so that's a vector. All right, so that means we're gonna, this is our vector here, 0, 4. We're gonna add nothing to x and add 4 to all our y's. When we do that, we're going to get our image, and that would be J prime, K prime, L prime. I was trying to color code this and keep all the points that go for each figure, the pre-image, the image, or the second image, and the operations all different colors. But I failed because that vector was supposed to, I meant to write it in black, but it doesn't really matter. All right, so now we're going to change our points according to the vector. So now x doesn't change at all. So that's just going to be 6, 10, 5. And then if we add 4 to all of our y coordinates, that's going to be 3, 2, and 1. So let's graph that. All right, so 6, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3. There's J prime. And 10, 2. That's K prime. And 5, 1 is, oops, right there, yeah, is L prime. And so here's our triangle. I didn't choose the best places to write my points because J and L are kind of crammed in there. All right, so that's our translation. And then we had a reflection in the y-axis. So when we reflect over the y-axis, I'll just keep it green. All right, we're going to, so I'll put reflect y-axis. Right, so remember when we reflect over the y-axis, the x becomes the opposite, and the y stays the same. Right? I just put an arrow here because we're not adding anything. Right? We're just changing it according to that rule. Right? And so then our second image, which would be J prime prime, K prime prime, L prime prime, make x's the opposite, so now that's -6, -10, -5, and don't do anything to the y's, 3, 2, 1. Right, and so now we can graph that. So we're going to have -6, 1, 2, oops, 1, 2, 3, 4, 5, 6, and up 3, right there, is going to be J prime prime, and K prime prime is going to be at 10, -10, 2. And L prime prime is at -5, 1. And there we go. There's our image. And see how easy that is, right? To keep everything straight and have everything go into the right location. Right? And always make sure you label your figures. Who is the image, the pre-image? The first image will have 1 set of prime marks. The second image has 2 sets of prime marks. So we'll do all of our composite transformations just like this. And here's the next one. This one's in your notes. All right, so let's first of all write down the points for A, B, C. And so sometimes my figure moves a little bit. There are no fraction amounts, I will tell you that. It didn't stay where it was supposed to, and it just accidentally changed size a little bit. So that's supposed to go there, and that's my intention. That's point 1, -1, and this here is the point 2, 3, 4. -1, and then we have 2, 2. All right, so let's write that down. All right, so we have A, B, C, and our matrix, and we have 1, -1, 4, -1, and 2, 2. I just always write that down first of all. All right, so now let's look at our first rule. It says to rotate 9 degrees clockwise about 0, 0, right? So we're not adding anything, but we're changing it. So now we got to think about what that looks like if we rotate 90 degrees clockwise. And then I'm just going to write in 0, 0, because I'm trying to write this without taking up too much space. All right, so if we're going 90 degrees clockwise, right, we're going to be going to the, turning to the right here to the next quadrant, right? So we're going to be kind of moving over here, right? So your X and Y always switch on the rotations, on the 90 degrees and the 270, and everything, so here, remember X is positive, Y is negative. Here, both are negative. There we go. Right? It's going to flip. It's going to be in the next position there, and it's got to be negative. And I'm assuming that negative will come up any day now. All right, so that's going to give us A prime, B prime, C prime. Okay, hello. Here comes part of it. I guess I picked up the pen too soon and it made my negative green. There we go. All right, so we're going to flip and change the signs. So all the y's there are going to be the x's and vice versa. And then we're going to change the sign on the second one. Right? So the -1, -1, 2 are going to be the x coordinates. And not 1, 4, 2, but -1, -4, -2. So see how easy it is to keep track of everything with a matrix. Our second one is we're going to reflect over the line y equals x. I have that graphed there. So that one's a little bit tougher because it's not where we can just write a rule, like switch the x's or add something. Right? We have to figure out how far away we are, right? And so then, where should we be? Right? So our next thing, we'll just write it in though, is we're going to reflect over x equals 1. There we go. Right. Now I'm just going to put an arrow here because there won't necessarily be a rule for us, but we'll still write down the points over there, right? Just so we can have them listed. And hopefully we can squeeze everybody in. Oops, on that last part there. Let me see if I can move over those words to give us just me a little bit more space. There we go. There we go. And so this is going to be A prime prime, B prime prime, C prime prime. One of those points isn't going to, I don't know why that keeps coming up. I did not hit the keyboard. One of these points is not going to change at all. You know which one's not going to change? It's the one that's sitting right on the line of reflection, right? Because this is x equals 1 right there. So A is not going to change at all. So we can just put -1, -1 there, and we can feel free to just graph that for A prime. All right, so B here is 1, 2, 3 to the right. So we're going to have to take 1 and subtract 3, because we're going to be going to the left. Right? So if we take 1 minus 3, that's going to be -2. So B here is going to be right here at -2. There it is, -2. That's going to be B prime. Right? So B prime is at -2, -1. Oops, and guess what I did? I did a bad thing. I forgot to graph our image after I did that. And I'm looking at that and going, that's not matching my matrix. That's another reason. This was the 90-degree rotation there. There's another reason to have matrix, because sometimes you accidentally forget and go back to the wrong figure. But see, it didn't match what I had on the other side. Although the -1, -1, well, that's only going to be right. That's not going to be right anymore, right? Because our image is not on the line of reflection. Oh, silly me. That's my second mistake. But everyone's allowed a mistake once in a while. You just got to fix it. All right, let's graph our figure after the rotation. I think we'll be doing a lot better. So -1, -1, it was right here. That would be A prime. B prime is at -1, -4. It's right here. And 2, we are, oh no, that's okay. That one, That one was positive. That's okay. All right, so 2, -2 is C. It's because C was in a different quadrant. So 2, right, so we're going to be now on the positive side. 1, 2, -2, 1, 2. And I'm going to get rid of that arrow there for the 90-degree rotation because otherwise we're going to run out of space. I think this podcast, this Nearpod, is going to have a part 1 and a part 2. All right, now let's graph it. And this here was C prime. All right, so there's what we look like after the 90-degree rotation. And my triangle does not look congruent. However, I think it is my drawing rather than my points. But let's double check that. So 1, 2, 3, 1, 2, 3. That is correct. That height there is 1, 2, 3. Oh, my graphing of points is in the wrong location because -2 is over. That's 3. Where did I go wrong? I didn't write down the wrong points. -1. It's a little confusing when I have the line of reflection already in there, but nope, that's because the blue line, let's move this blue line out of the way. Oops, or no, I guess it's stuck. All right, so here is 0, 0. Somewhere I wrote down something wrong. There we have 0, 0. Okay, and so that's -1, or 1, -1, excuse me. And then B is at 2, 3, 4, -1, that's correct. And C is at 1, 2, 1, 2. That's in the right location. All right, so then we rotated, so they flipped and became the second one becomes the opposite. So we have -1, -1, -1, -4, 2, -2. Why is that point does not look like the right location? It should go there. Well, something is wrong and I can't figure out why. So I'm going to end this podcast right now, figure out what I did wrong so that we can go over that, we can fix it and do it good. Right? And then we're going to pick up with this problem and this problem. And here's the vectors all in there too. And then we'll talk about figuring out composite transformations, and we'll do a couple together. And I put your whiteboard practice in your notes, and then we'll do this one. And then the final whiteboard practice is also in your notes because I had a little extra space. All right, so I'm going to end this podcast. I'm going to fix that problem, and we'll come right back to it. All right, bye for now.